All right. Welcome, everyone, to KITP. I'm Lars, Bildsten, the director here. I really want to thank all of you for coming. I also want to thank all of our speakers for coming today to present to all of you. We've been doing this teachers conference for a long time, and there's Greg. So Greg, I want to thank Greg for all of his hard work that he's been doing to pull this together. So thank you, Greg. Lance Dixon, who I'm going to hand the mic over to in a minute to get the first session launched, has been working with Greg to corral the speakers so that we can have a great lineup for all of you. But I first want to start with asking the question I always start with any conference. For how many of you is this your first time in the building this morning? Raise your hand high. 1, 2, high. Yeah, I can't see if you. 4. So we have a lot of return customers, and of course the speakers have been here before. So just very briefly to tell you a little bit about the KITP, all of you more or less know about it. We've been on here at UC Santa Barbara since 1979. So we're approaching our 40th year of operations, and we've been doing this teachers conference probably since at least almost 15 years. And I know some of you have tried to be here 15 times. Some of you have been here easily 8 times, I think. And I would encourage all of you to keep spreading the word so that we can get more new people in the room. Maybe this year it was a little bit difficult because of the timing. We're hoping that our next year's teachers conference will be on March 25. We're expecting the topic to be discovery of gravitational waves with LIGO. We expect that will be an exciting time. All of you have already heard about the first detection, but I've been told there are more to come. And mathematically, there better be more to come if the first one was as strong as it was. So Greg and I will start working on that, but we do intend to do it in mid-March. And we think that's a good time of year, maybe better than May. I'm not sure. I'm getting head nods in both sides. Okay. So a few logistical things. So please do wear your name tags. We do have 3 programs in the building, and they'll all think the food that's in the courtyard is for them, not for you. And so that helps our staff in terms of managing things. You're welcome to play the piano actually during breaks if you want to. If there's any great piano players, we're happy to have you tickle the ivories. The staff will be wearing name tags. All of you have already met. Claudia is here, as well as Lori, who's out there doing reimbursement. So please be sure you do that. And you've maybe met Gus already on the bus. So I think those are the major things I want to announce. Many of you have been here before, so I want to quickly hand this over to Lance and have him get things started. Lance.
All right, thanks a lot, Lars. It's a real pleasure to be able to organize this event. I'm a newbie at it compared to many of you, but the idea was to put together a day of talks centering around modern particle physics, and especially what's going on in Geneva, where the International Lab CERN has constructed the Large Hadron Collider, and there are a number of detectors that have been taking data. And there have been some pretty incredible discoveries already, including the Higgs boson, which many of us remember July 4th, 2012, when the discovery was announced. And it's been very exciting to determine the properties of this new particle. So we're going to hear some about the discovery from Joe Incandela. We'll get back to in a second. And then Laura Reina, who's sitting in the back, she'll tell us about whether and how it fits our theoretical picture and how we think about it theoretically. And then we're going to talk about going into the unknown. The Higgs boson is the last particle of this edifice we call the Standard Model, which describes all the elementary particles, except maybe the gravitons seen by LIGO, and their interactions in a quantum mechanical framework. But we have lots of reasons to think that it's not the end of the story. And so Brian Weber is going to tell us about some of those reasons. And then Tom Lecomte is going to explain how we search for physics beyond the Standard Model. So sort of having given you a brief overview, I should mention we also have a few other session chairs. And besides all the formal questions, at lunchtime you'll have a chance to sit at a table with a physicist and ask more questions over food and stuff like that. So I guess I'll then turn to our next speaker, who is Joe Incandela. He's local from UCSB, and he's a former spokesperson of the CMS collaboration, which is one of the roughly 3,000 member collaborations at the LHC. There are a few other smaller, say 1,000-member collaborations. But CMS together with Atlas are the two detectors that collected the data that gave the evidence for the Higgs boson. And Joe Incandela, along with his the leader of the Atlas collaboration, Fabiola Giannotta, they announced to the world on July 4th, 2012, that this new particle had been seen. Without saying any more about that, let's welcome Joe, and he'll tell us all about it.